What if I told you there's a place in the universe so strange, so utterly baffling, that it shouldn't exist at all? Picture this, a tiny, faint speck of light drifting through the cosmic void. A dwarf galaxy so unassuming you might overlook it entirely. But don't let its size fool you. This little cosmic rebel defies everything we thought we knew about how galaxies form, how they survive, and even how the universe itself operates. Astronomers are scratching their heads, textbooks are being rewritten, and the very laws of physics seem to wobble in its presence. This is the story of the forbidden dwarf galaxy, a cosmic outlaw that's turning our understanding of the universe upside down. Imagine gazing up at the night sky, where every twinkling star is part of a grand, orderly dance governed by gravity and dark matter. Now imagine finding a rogue performer, one that moves to its own rhythm, breaking every rule in the cosmic playbook. That's exactly what scientists stumbled upon when they discovered this enigmatic dwarf galaxy. It's too small, too isolated, and yet it's thriving. According to everything we know, it should have been torn apart by now, its stars scattered into the darkness. But there it sits, defiant, challenging the very foundations of astrophysics. What secrets is it hiding, and what does its existence mean for our understanding of the cosmos? This isn't just a curiosity for astronomers, it's a full-blown mystery that could rewrite the rules of the universe. Think about it. If this tiny galaxy can exist against all odds, what else might be out there waiting to shatter our assumptions? The more we learn, the more we realize how much we don't know, and that's the thrilling part. This isn't just a story about distant stars and cold, empty space. It's a reminder that the universe is still full of surprises, still capable of leaving us breathless with wonder. So buckle up, because we're about to dive into one of the most perplexing cosmic puzzles of our time, a galaxy that shouldn't be here, and the mind-bending questions it forces us to ask. The discovery of this cosmic misfit didn't happen by accident. It was the result of painstaking observations and a bit of luck. Back in 2013, astronomers using the Hubble Space Telescope were scanning the vast emptiness between larger galaxies, searching for the faintest glimmers of light that might reveal hidden cosmic neighbors. And there, in the quiet darkness, they spotted it, a tiny, dim smear of stars barely noticeable against the blackness of space. At first glance, it seemed unremarkable, just another dwarf galaxy among countless others. But as they studied it more closely, something didn't add up. This galaxy, later named NGC 1052DF2, was unlike anything they'd seen before. Most dwarf galaxies orbit larger ones, clinging to them like moons around a planet. But this one was completely isolated, drifting alone in a region of space where nothing like it should exist. Even stranger, it had almost no dark matter, the invisible cosmic glue that holds galaxies together. Without it, stars should have scattered apart long ago, yet here they were, stubbornly holding on. The discovery sent shockwaves through the astronomy community. One researcher called it the galaxy that shouldn't exist, while others scrambled to double-check their instruments, convinced there had to be a mistake. The initial skepticism quickly turned to fascination as more telescopes turned their gaze toward the anomaly. The Keck Observatory in Hawaii, with its massive 30-meter mirror, confirmed the absence of dark matter. The Very Large Array radio telescopes searched for traces of gas or dust that might explain its survival, and found nothing. Every new observation only deepened the mystery. Here was a galaxy that defied the most fundamental rules of cosmic structure, a tiny rebel that somehow thrived where it should have vanished. Scientists were left with two unsettling possibilities. Either our understanding of dark matter was deeply flawed, or this galaxy was evidence of something entirely new at work in the universe. What made the discovery even more tantalizing was the timing. Just a year earlier, astronomers had found another bizarre dwarf galaxy, NGC 1052DF4, also lacking dark matter. Now, with two examples in hand, it was harder to dismiss the phenomenon as a fluke. Suddenly, the question wasn't just how did this happen, but how many more are out there? The hunt was on, and with it came a humbling realization. The universe, it seemed, was still full of surprises, waiting to upend even our most deeply held beliefs. Nestled in the cosmic expanse about 65 million light-years from Earth, this peculiar dwarf galaxy floats in near total isolation, far from the bustling crowds of galaxies that typically dominate such vast stretches of space. Most dwarf galaxies are found clustered around larger galactic neighbors like moths drawn to a flame, gravitationally tethered to their colossal hosts. But this one, designated NGC 1052DF2, drifts alone in the sparse outskirts of the Coma Sculptor Cloud, a vast filament of galaxies that threads through the darkness. Its solitude is striking. Imagine a single firefly hovering in the void, miles from the nearest street lamp, glowing faintly yet defiantly against the night. That's how astronomers first spotted it, a dim, ghostly smudge where nothing should be. Its location is the first clue that something unusual is at play. Normally, galaxies this small and faint survive only because they're satellites of larger galaxies, protected by their host's gravitational embrace. But this one exists in a cosmic no-man's land, far from any major galaxy that could shield it from the tidal forces of the universe. Even more perplexing, it's not just isolated, it's impossibly stable. Without the anchoring pull of dark matter or the shelter of a larger galactic neighbor, its stars should have long since scattered like marbles dropped on a tilting floor. Yet here it is, holding itself together against all odds, a cosmic Houdini escaping the very forces that ought to have torn it apart. Adding to the intrigue is its environment. The Coma Sculptor Cloud, where it resides, is a relatively quiet region of space, no violent galactic collisions, no swirling maelstroms of gas and dust. It's the last place you'd expect to find a rule-breaking anomaly like this. Some scientists speculate that its strange properties might be linked to its loner status. Could it have been ejected from a larger galaxy long ago, flung into the void like a cosmic castaway? Or is it the survivor of some ancient, unseen cataclysm that stripped away its dark matter? Theories abound, but one thing is certain: its location deepens the mystery rather than solves it. The more astronomers study this lonely rebel, the more questions arise. Its distance from Earth, 65 million light-years, means we're seeing it as it was in the age of the dinosaurs, a frozen snapshot of its defiance against cosmic norms. What's happened to it in all that time? Has it quietly disbanded, its stars finally succumbing to the inevitable? Or is it still out there, persisting against the odds, a flickering enigma in the darkness? Every answer only leads to more questions, and that's what makes this dwarf galaxy not just a scientific curiosity but a beacon, challenging us to rethink everything we thought we knew about the universe's grand design. At first glance, this cosmic oddity might seem like just another speck in the vastness of space, but zoom in, and its strangeness becomes impossible to ignore. Spanning a mere 7,000 light-years across, NGC 1052DF2 is puny even by dwarf galaxy standards. To put that in perspective, our Milky Way stretches over 100,000 light-years, making this rebel galaxy barely a fraction of its size. But it's not just its small stature that stands out. It's what's inside, or rather, what isn't there. Most dwarf galaxies are dense and compact, packed with stars clinging tightly together like passengers on a crowded subway. This one, though, it's almost eerily sparse, with stars scattered so thinly that you could fly between them for light years without spotting a single neighbor. The shape of this galactic misfit only adds to its mystery. Unlike the chaotic, lumpy structures of typical dwarf galaxies, often warped by the gravitational tug of war with larger neighbors, NGC 1052DF2 is bizarrely smooth and symmetrical. Imagine a perfectly spun spiderweb, delicate yet orderly, floating undisturbed in the cosmic breeze. That's the kind of pristine structure astronomers observed, one that suggests an unusually tranquil history. No violent collisions, no gravitational bullying, just a quiet, solitary existence that defies the rough and tumble norms of galactic evolution. Then there's the matter of its stars themselves. Most dwarf galaxies are filled with ancient, reddish stars, relics from the early universe that burn slowly and dimly. But this one baffled researchers by hosting relatively young blue stars, the kind you'd expect to find in vibrant, star-forming regions, not in a tiny, isolated galaxy. It's like discovering a lone, thriving sapling in the middle of a desert where nothing should grow. Even more puzzling, these stars aren't just young, they're moving at a snail's pace compared to stars in other galaxies, drifting lazily through space as if unaware of the cosmic rules that usually govern stellar motion. The absence of dark matter is the final twist in this galactic enigma. In a typical dwarf galaxy, dark matter acts like an invisible scaffold, providing the gravitational glue that keeps stars from flying apart. Remove it, and the galaxy should unravel like a sweater with its threads cut. Yet here, against all expectations, the stars of NGC 1052DF2 cling together without it, like a tower standing tall despite missing its foundation. How? That's the million-dollar question. Some theorize it might have been stripped away by a close encounter with another galaxy, while others wonder if this galaxy formed in some freakish, dark matter-free pocket of the universe. Either way, its very existence forces us to confront a humbling truth. The cosmos might have more tricks up its sleeve than we ever imagined. Scientists don't throw around the word forbidden lightly. It's reserved for things that break the rules so fundamentally, they shake our understanding of reality. And this dwarf galaxy, it's not just bending cosmic laws, it's snapping them in half. The term forbidden sticks because it defies two pillars of astrophysics: how galaxies hold themselves together and how stars are even born in the first place. Let's start with dark matter. Every galaxy we've ever studied, from spirals like the Milky Way to the tiniest dwarfs, is cocooned in a massive halo of this invisible stuff. It's the universe's scaffolding, the hidden hand that keeps stars from flying apart. But this galaxy, its dark matter is missing 99% of it gone. It's like finding a skyscraper standing tall with no steel frame, or a souffle that stays perfectly risen without eggs. The numbers just don't add up. Then there's the star formation puzzle. In a typical dwarf galaxy, stars are born slowly, in fits and starts, as gravity pulls together scarce gas and dust over eons. But here, young blue stars gleam like cosmic teenagers, hinting at a burst of rapid formation in the recent past. That's bizarre for a galaxy so small and isolated. Without dense clouds of gas or the gravitational seed money of dark matter, there's no obvious way those stars should exist. It's like stumbling upon a bustling city in the middle of a desert. No water, no roads, no explanation for how it thrives. The real kicker, this isn't a one-off glitch. With a second dark matter-free dwarf galaxy found nearby, NGC 1052DF4, the plot thickens. Either we're witnessing an impossible statistical fluke, or our models of galaxy formation are missing something huge. Some theorists suggest these rebels might be tidal dwarfs, galaxies born from debris ripped away during violent collisions between larger galaxies. Others wonder if dark matter interacts in ways we've never imagined, leaving ghostly footprints we can't yet detect. But every explanation feels like trying to fit a square peg into a round hole. The universe, it seems, has a rebellious streak, and these galaxies are its most brazen rule breakers. The absence of dark matter in this dwarf galaxy isn't just unusual, it's cosmic heresy. For decades, dark matter has been the cornerstone of astrophysics, the unseen force shaping the universe's grand design. Every galaxy we've observed, from sprawling spirals to the tiniest dwarfs, is embedded in a vast halo of this mysterious substance. It's what prevents galaxies from flying apart, the invisible hand guiding the dance of stars. But NGC 1052DF2 flips that script entirely. Measurements show it contains less than 1% of the dark matter predicted by our models. It's like finding a car speeding down the highway without an engine, a violation of everything we thought we knew about how the universe works. To grasp just how bizarre this is, consider how dark matter was discovered in the first place. Back in the 1930s, astronomer Fritz Zwicky noticed that galaxies in the Coma cluster were moving far too quickly to be held together by visible matter alone. His conclusion, something unseen, something dark, must be providing the extra gravitational glue. Fast forward to today, and dark matter isn't just a theory. It's the backbone of modern cosmology, woven into simulations, equations, and even the way we map the cosmos. Entire galaxies form within its gravitational wells, and without it, the universe as we know it wouldn't make sense. Yet here's this lone rebel existing in defiance of that very framework. The implications are staggering. If dark matter isn't universal, what does that mean for our understanding of gravity? Could Einstein's theory need revising, or is there some exotic form of matter we haven't accounted for? Some researchers have proposed radical alternatives like modified Newtonian dynamics, MN for short, a theory that tweaks the laws of gravity to explain certain cosmic motions without invoking dark matter. But even MN struggles to explain this galaxy's extreme outlier status. Others wonder if dark matter might interact in ways we don't yet understand, perhaps clumping differently in isolated regions of space. Then there's the eerie coincidence of its neighbor, NGC 1052DF4, also lacking dark matter. Two misfits in the same cosmic neighborhood can't be dismissed as flukes. It suggests there might be an entire class of galaxies lurking in the shadows, quietly undermining our textbooks. Could these be remnants of a larger galaxy torn apart, their dark matter stripped away by some ancient collision? Or are they the result of a rare, freakish process we've yet to witness? Every possible explanation feels like grasping at cosmic straws, a reminder that the universe enjoys keeping us on our toes. What's clear is this: the forbidden dwarf galaxy isn't just a curiosity, it's a crack in the foundation of astrophysics. Its existence forces us to confront the uncomfortable truth that our models might be incomplete, that the universe still holds secrets we're only beginning to glimpse. And that's what makes science so thrilling. Every anomaly, every rule breaker is an invitation to dig deeper, to question what we think we know. Because if there's one thing history teaches us, it's that the cosmos never runs out of surprises. The stars in NGC 1052DF2 tell a story that doesn't just puzzle astronomers, it outright contradicts the cosmic rulebook. Normally, dwarf galaxies are cosmic relics, packed with ancient, slow-burning stars that formed billions of years ago. But this one, its skies are dotted with young, blue stars, the kind that burn hot and bright before flaring out in celestial fireworks. It's like finding a nursery full of newborns in a retirement home, a sight so out of place it demands an explanation. What makes these stars even more baffling is where they're born, or rather where they aren't. Star formation requires dense clouds of gas, the raw material for stellar birth. Yet this galaxy is eerily empty, lacking the vast reservoirs of hydrogen and dust that typically fuel such activity. Without these ingredients, it's like expecting a bakery to produce bread without flour. So how did these stars come to be? One theory suggests a fleeting, frenzied burst of star formation in the recent past, a brief cosmic spree that exhausted its gas supply almost instantly. But what triggered it? No nearby galaxies loom close enough to have stirred the pot gravitationally, leaving scientists scrambling for alternatives. The plot thickens when you examine how these stars move. In most galaxies, stellar orbits are chaotic, a frenetic jumble shaped by dark matter's gravitational pull. Here, though, the stars drift with an almost lazy grace, their motions sluggish and unperturbed. It's as if the galaxy exists in a pocket of cosmic calm, untouched by the usual gravitational tugs that warp and distort its peers. This tranquility only deepens the mystery. If no external force stirred the gas to form stars, and no dark matter anchors their motion, what invisible hand is orchestrating this delicate balance? Even more perplexing is the galaxy's lack of metallicity, the telltale chemical fingerprints left by generations of stars. Young stars typically inherit heavier elements from their predecessors, the cosmic leftovers of supernova and stellar winds. But these stars are curiously pristine, their compositions unusually pure for their apparent youth. It's another inconsistency that points to a formation story unlike anything we've seen before. Could they have formed from gas so untouched by earlier star death that it defies conventional timelines? Or is there some exotic process at work, one that rewrites the rules of stellar chemistry? The implications ripple far beyond this one galactic oddity. If stars can form and persist under such improbable conditions, what else might be possible in the universe's quiet corners? Could there be entire populations of galaxies thriving in defiance of our models, hidden in the darkness just beyond our telescope's reach? Every new observation of this cosmic rebel chips away at the neat categories we've built, reminding us that the universe is far stranger, far more inventive than we ever imagined. And that's the thrill of discovery, not just finding answers, but realizing how many questions we've yet to ask. Globular clusters are the ancient sentinels of the cosmos, dense, spherical swarms of stars that orbit galaxies like bees around a hive. In most dwarf galaxies, they're as common as freckles on a redhead, relics from the universe's chaotic youth. Yet when astronomers turned their gaze to NGC 1052DF2, they found something startling, not a single globular cluster in sight. It's like stumbling upon a forest where every tree has vanished, leaving only empty air where roots should be. This absence isn't just peculiar, it's another glaring red flag that this galaxy operates by rules we don't yet understand. Globular clusters are more than cosmic decoration, they're time capsules. Typically, these clusters form during a galaxy's most violent early years, when collapsing gas clouds and rampant star creation litter space with these glittering knots. Their presence in dwarf galaxies is so expected that their absence raises immediate questions. Where did they go? Were they never there to begin with? For NGC 1052DF2, the leading theory is as unsettling as it is simple. This galaxy might never have had them. Without the gravitational anchor of dark matter, the turbulent conditions needed to birth globular clusters may have simply never materialized. Imagine trying to whip cream in a bowl with no bottom. The chaos never coalesces into structure. There's another, more dramatic possibility. Perhaps this galaxy once did host globular clusters, but something ripped them away. Galactic collisions can tear clusters loose, sending them careening into intergalactic space like marbles spilled from a jar. But here's the catch: NGC 1052DF2 shows no scars of such violence. Its stars move in serene, undisturbed orbits, with no telltale trails of scattered clusters or distorted shapes. That leaves scientists with a paradox. Either the clusters were gently, mysteriously plucked away without a trace, or this galaxy was born into existence already missing a piece of its cosmic DNA. The implications ripple outward. If dark matter truly shapes the formation of globular clusters, its absence here might explain their disappearance. Or perhaps the clusters evaporated over eons, their stars dispersing like smoke in the wind due to the galaxy's unusually weak gravity. Some researchers even speculate that this galaxy's strange isolation played a role without nearby galaxies to stir its primordial gas. The dense pockets needed for cluster formation might never have collapsed. Every explanation feels like grasping at shadows, a reminder of how much we still don't know about the invisible scaffolding of the universe. What makes the mystery even richer is the contrast with other cosmic oddballs. Take the ultra-diffuse galaxy Dragonfly 44, which boasts a staggering 99.99% dark matter content, yet still manages to host a healthy family of globular clusters. Why does one dark matter-deficient galaxy lack them entirely while another overflows? The universe, it seems, enjoys throwing curveballs, challenging us to rethink the link between dark matter and these stellar fossils. With each new observation, the puzzle grows more complex, revealing not just gaps in our knowledge, but entire chasms we didn't know existed. The missing globular clusters aren't just a footnote in this galaxy's story, they're a clue to something far bigger. Their absence hints at a universe where galactic formation isn't as uniform as we once imagined, where outliers like NGC 1052DF2 force us to question the very definitions of normal. Whether through an unseen astrophysical process or some quirk of cosmic history, this silent enigma reminds us that the night sky still holds secrets waiting to unravel our most cherished theories. And that's the beauty of astronomy. Every anomaly, every rule breaker is a whisper from the cosmos urging us to look deeper. The stars in this forbidden dwarf galaxy don't just sit still, they move in ways that defy every expectation. Normally, in a galaxy this size, you'd expect stars to zip along at breakneck speeds, held in check by the immense gravitational pull of dark matter. But here, the opposite is true. These stars drift lazily, like leaves floating on a calm pond, their motion so sluggish they barely seem bound by gravity at all. It's as if someone dialed down the universe's natural forces just for this one corner of space. Measurements reveal their speeds are a mere 25 kilometers per second, far slower than the hundreds you'd see in a typical dwarf galaxy. To put that in perspective, imagine two cars on a highway, one cruising at a leisurely pace, the other racing past like a bullet. In cosmic terms, this galaxy's stars are barely idling, while their counterparts elsewhere are flooring it. This sluggishness isn't just odd, it's a direct challenge to our understanding of gravity. Without dark matter's invisible grip, these stars should have flown apart eons ago. Yet somehow they linger, clinging together in defiance of the math. The real head-scratcher is their motion isn't just slow, it's eerily uniform. In most galaxies, stars follow chaotic, crisscrossing orbits like bees buzzing around a hive. But here, they move in near-perfect harmony, as if guided by an unseen conductor. There's no wild scattering, no gravitational tug of war distorting their paths. This strange synchrony suggests something even more radical, that the laws of gravity might operate differently in this pocket of the universe. Could Einstein's equations need tweaking in environments devoid of dark matter? Or is there some exotic force at work, one we haven't even named yet? Theories abound, but none fit neatly. Modified Newtonian dynamics, or MUND, a fringe idea that tweaks gravity's rules, gains traction here, as it predicts slower stellar motions in dark matter-free zones. Yet even MUND struggles to explain the extremes seen in this galaxy. Others propose the stars might be the survivors of a catastrophic event, like a high-speed collision that stripped away both dark matter and kinetic energy, leaving behind a ghostly, slow-motion remnant. But where's the evidence of such violence? The galaxy's pristine, undisturbed shape offers no clues. Then there's the outlier factor. A handful of stars within the galaxy move faster than the rest, clustering in small, unexpected knots. These speedsters add yet another wrinkle, hinting at pockets of unseen mass or gravitational quirks we can't yet map. It's like watching a ballet where most dancers move in slow motion only to spot a few suddenly sprinting across the stage. What's propelling them? A hidden stellar corpse, a rogue black hole too small to detect? Or is this just another symptom of a cosmos that thrives on throwing us curveballs? Every observation deepens the enigma. If stars can move this slowly without dark matter's anchor, what does that mean for our models of galaxy formation? Are we missing a fundamental piece of physics, or is this galaxy the exception that proves the rule? The answers might lie not just in the stars themselves, but in the empty spaces between them, the silent, invisible gaps where the universe's secrets often hide. One thing's certain, until we crack this velocity mystery, our map of the cosmos remains gloriously incomplete. If this dwarf galaxy were a reclusive artist, its neighbors would be the baffled critics trying to make sense of its work. Most galaxies live in bustling communities, constantly nudging and shaping one another through gravitational encounters. But NGC 1052DF2 floats in cosmic isolation, with no close companions to explain its oddities, or so it seems at first glance. Peer deeper, though, and clues emerge that its story might be entwined with the wider galactic neighborhood after all. About 40 million light-years away looms the massive spiral galaxy NGC 1052, a potential key to this puzzle. Some astronomers speculate our enigmatic dwarf might once have been its satellite, violently ejected in a gravitational slingshot maneuver billions of years ago. Picture a game of cosmic pinball. If two larger galaxies collided long ago, their gravitational chaos could have hurled this tiny galaxy into the void, stripping away its dark matter like feathers torn off by a strong wind. The problem: no visible debris trail or distorted shapes reveal such a dramatic exit, leaving this theory hanging on thin evidence. Then there's NGC 1052DF4, its equally mysterious sibling galaxy. Found drifting at a similar distance, this second dark matter-free oddball suggests these outliers might share a common origin story. Were they both birthed from the same ancient collision, cast adrift like twin lifeboats from a shipwreck? If so, where's the wreckage? The pristine condition of both galaxies contradicts the violent turbulence such an event should leave behind. It's like finding two perfectly intact teacups in the middle of a battlefield. No cracks, no dust, just quiet defiance of expectations. The neighborhood holds other curiosities. The Coma Sculptor Cloud, the vast filament of galaxies where this rebel resides, is unusually sparse for producing such rarities. Normally, extreme galactic oddities emerge from dense clusters where gravitational interactions run rampant. Here, the quiet outskirts should be the last place you'd find rule breakers. Yet their presence hints at unseen forces, perhaps vast, diffused dark matter currents moving beneath the observable universe like subterranean rivers, sculpting galaxies in ways we can't yet detect. Could these galaxies be cosmic tombstones, marking the graves of long-vanished giants? One provocative theory suggests they're the remnants of a massive galaxy torn apart by tidal forces, its dark matter scattered while leftover stars regrouped into these fragile new structures. If true, it would mean we're looking at celestial phantoms, the faint echoes of a catastrophic event lost to time, but without evidence of a perpetrator, no nearby galaxy massive enough to wield such destructive power. This idea remains more poetry than proof. What's clear is this: the silence of this galactic neighborhood speaks volumes. The absence of obvious interactions only deepens the mystery, forcing us to consider wilder possibilities. Maybe dark matter isn't missing here. Maybe it never existed in these parts to begin with. Could certain cosmic voids operate by different rules, creating pockets where galaxies form through processes we've yet to imagine? Every thread of inquiry frays at the edges, leaving us with more questions than answers. And that's exactly what makes astronomy so exhilarating: the universe's stubborn refusal to fit neatly into our boxes. One thing's certain: if this galaxy truly stands alone, untouched by its neighbors, that isolation might be the greatest clue of all. Its defiance of cosmic norms could reveal gaps in our understanding far more profound than any local interaction could explain. Perhaps the real story isn't about where this galaxy has been, but about how the universe works in places we're only beginning to see. When confronted with a cosmic anomaly as baffling as this, scientists don't just shrug, they rewrite the playbook. The forbidden dwarf galaxy's defiance has spawned a zoo of wild theories, each attempting to crack its mystery without breaking the laws of physics. At the forefront is modified Newtonian dynamics, or MND, a radical idea that suggests gravity itself works differently on galactic scales. Forget dark matter, MND argues we've been misreading the universe's gravitational fine print all along. In this framework, gravity doesn't fade as quickly over distance as Newton or Einstein predicted, which could explain why stars in this galaxy move so sluggishly without dark matter's pull. It's like discovering water flows uphill in one particular valley. You'd question the laws of hydraulics before insisting the valley's haunted, but MND isn't without its flaws. While it accounts for the galaxy's slow-moving stars, it stumbles over other cosmic oddities like the Bullet Cluster, where colliding galaxies clearly separate from their dark matter halos. That's led some researchers to propose hybrid models: dark matter and tweaked gravity, a cosmic have-your-cake-and-eat-it-too scenario. Others suggest this galaxy might be a rare exception, a place where dark matter was somehow scrubbed away. Picture a black hole acting as a cosmic vacuum, sucking dark matter out of the galaxy like a straw in a milkshake. Primordial black holes, those hypothetical leftovers from the Big Bang, could be the culprits. These ancient, invisible objects might have wandered through, stripping dark matter while leaving visible stars untouched. Then there's the tidal disruption theory, which paints a more violent backstory. Imagine a massive galaxy swinging too close to this dwarf, its gravitational tides ripping away dark matter like a thief in the night. The catch: no nearby galaxy shows signs of such a robbery, and the dwarf's pristine structure lacks the scars expected from a gravitational mugging. Still, some argue the evidence could have faded over billions of years, leaving behind a ghostly victim with no fingerprints. Perhaps the most mind-bending idea involves alternate dark matter. Not the cold, collisionless variety we've modeled for decades, but warm or fuzzy dark matter. Particles so light and wispy they behave more like a diffuse fog than an anchoring scaffold. In this scenario, dark matter might exist here after all, just in a form so ethereal our instruments miss it. It's the equivalent of searching for a mountain and overlooking the mist clinging to its slopes. Or maybe, just maybe, this galaxy is a cosmic mirage. Some simulations suggest it could be a failed galaxy, a patch of stars that never fully coalesced, like a cake pulled from the oven too soon. Without the density to retain dark matter, it stumbled into existence against all odds, a celestial Hail Mary. What ties these theories together is their audacity. Whether tweaking gravity, invoking unseen black holes, or rewriting dark matter's rulebook, each dares to question foundational truths. And that's how science moves forward, not by polishing old ideas, but by letting anomalies like this galaxy sandblast them until something new shines through. For now, every hypothesis remains a work in progress, a testament to the universe's talent for keeping us guessing. Supercomputer simulations are the ultimate cosmic test kitchens, where scientists throw in the known ingredients of the universe and expect galaxies to bake according to the recipe. Dark matter, gas, gravity mix them together and voila, a virtual galaxy that mirrors the real ones we observe, except when it doesn't, and this forbidden dwarf galaxy. It's the dish that keeps burning every simulation to a crisp. No matter how many times astrophysicists tweak the parameters, no matter how powerful the supercomputer, they simply can't cook up a galaxy like this one under the current rules of cosmology. It's like following a cake recipe to the letter, only to pull a pizza out of the oven. The failure is as consistent as it is humbling. Simulations like Illustris, Eagle, and Millennium have spent millions of processor hours recreating cosmic evolution, churning out stunningly accurate virtual universes where spiral galaxies whirl and dwarf galaxies cluster exactly where they should. But introduce the specs of NGC 1052DF2, its lack of dark matter, its sparse stars, its eerie stability, and the models break down every time. The simulations either produce galaxies drowning in dark matter or ones so fragile they dissolve faster than sugar in hot tea. Replicating this cosmic misfit isn't just hard, it's seemingly impossible under the standard cosmological playbook. What makes these failures so alarming is what they imply about our foundational theories. The lambda-cold dark matter model, or LCDM, the reigning framework for how the universe structures itself, relies on dark matter as the invisible architect sculpting galaxies within its gravitational wells. Remove dark matter from the equation and the model predicts cosmic chaos, galaxies that either never form or collapse into stellar confetti. Yet here's this dwarf galaxy floating serenely without it, like a house standing firm with no foundation. If our best simulations can't account for its existence, does that mean LCDM is missing a chapter, or worse, is the entire story wrong? Some scientists argue the simulations might be overlooking subtle physics, like the way gas cools or stars redistribute mass over time. Others suspect the key lies in extreme, 1 in a billion scenarios, perhaps a freak tidal interaction or a collision so precise it stripped dark matter without leaving a trace. But even these tuned explanations feel like forcing a square peg into a round hole. The more plausible and unsettling possibility is that we're missing something fundamental. Could dark matter interact with itself in ways we haven't modeled? Might there be unknown forces at play in the universe's quiet corners, shaping galaxies by rules we've yet to write? The stakes are higher than just one oddball galaxy. If simulations can't reproduce outliers like this, how many other cosmic phenomena might we be misreading? Every failed model is a crack in the edifice of modern cosmology, a hint that the universe's instruction manual might have pages we've never seen. And that's the real lesson here. Anomalies aren't just wrinkles to smooth out, their signposts pointing to the next frontier of discovery. Until our simulations can conjure a galaxy like this one from first principles, we're not just missing answers, we might be missing entire questions. This isn't the first time the universe has thrown astronomers a curveball. History is littered with cosmic oddities that forced us to rethink the rules. Take Hoag's object, discovered in 1950 by astronomer Art Hoag. At first glance, it looked like a perfect ring of stars encircling an empty void, a celestial bulls, defying the messy spiral or elliptical shapes of typical galaxies. For decades, no one could explain how such a structure could form naturally. Was it a collision frozen in time, a freak of gravitational physics? Even today, theories range from ancient galactic mergers to bizarre resonance patterns in rotating gas. Like our forbidden dwarf galaxy, Hoag's object refused to fit the mold, becoming a poster child for cosmic exceptions. Then there's the enigma of ultra-diffuse galaxies, ghostly, sprawling collections of stars so faint they're nearly invisible against the blackness of space. When astronomers first spotted them in the 1980s, they seemed impossible. How could something so large and sparse hold itself together? Their existence hinted at unseen reservoirs of dark matter, far exceeding the visible stars. But the plot twisted with galaxies like Dragonfly 44, an ultra-diffuse behemoth that's 99.99% dark matter, and then again with our dark matter-free rebel, NGC 1052DF2. The universe, it seems, delights in serving up opposites just to keep us guessing. Even older mysteries set the stage. In the 1920s, astronomer Edwin Hubble's discovery of galaxies beyond the Milky Way shattered the notion that our galaxy was the universe. Later, quasars' blazing cores of distant galaxies bewildered scientists with their impossible energy output. Each breakthrough began as an anomaly, a crack in the facade of what we thought we knew. What makes our forbidden dwarf galaxy special isn't just its defiance, it's the timing. Its discovery comes at an era when cosmology feels settled, with dark matter theory neatly explaining galactic behavior. This outlier doesn't just add to the list of cosmic oddballs, it targets the very foundation of modern astrophysics. Perhaps the closest historical parallel is the Pioneer anomaly. In the 1990s, scientists noticed the Pioneer spacecraft slowing down slightly more than predicted as they drifted toward the edge of the solar system. For years, no one could explain it. Was it unseen gravity? A flaw in Einstein's equations? Eventually, the culprit turned out to be something mundane, heat radiating unevenly from the probes. But for a while, it threatened to upend physics. Our dwarf galaxy poses a similar tantalizing threat, except this time there's no simple answer waiting in the wings. What ties these anomalies together isn't just their strangeness, it's their stubborn refusal to be ignored. They're the universe's way of nudging us, reminding us that every time we think we've got it all figured out, the cosmos has other plans. And that's the thrill of discovery, not just finding answers, but learning how much more there is to question. Whether this dwarf galaxy becomes a footnote or a revolution in the textbooks, one thing's certain: it's earned its place in the hall of cosmic rule breakers. When news of the forbidden dwarf galaxy first broke, the astronomy community didn't just raise eyebrows, it erupted. Dr. Pieter van Dokkum, the Yale astronomer who led the discovery team, called it the galaxy that shouldn't exist, a phrase that ricocheted through headlines worldwide. Colleagues were skeptical at first, demanding double and triple checks of the data. "I thought there had to be a mistake," admitted Dr. Shani Danieli, a co-discoverer, but the numbers held up every time. Across observatories, telescopes swung toward this cosmic outlier, as if the scientific community needed to see it with their own eyes to believe it. The public reaction was even more electric. Social media lit up with memes comparing the galaxy to everything from a rebellious teenager to a glitch in the Matrix. Reddit threads exploded with theories, wild, serious, and everything in between. One viral tweet read, "The universe saw our physics textbooks and said, 'Hold my dark matter.'" Even beyond the jokes, there was a tangible sense of awe. People who'd never Googled dwarf galaxy before found themselves falling down rabbit holes about cosmology, marveling at how much we still don't know. But the real drama unfolded in academic circles. Conference halls buzzed with heated debates. Traditionalists argued the galaxy must have some hidden dark matter, just in a form we couldn't detect. Others saw it as vindication for fringe theories like MUND. Dr. Stacy McGaw, a Vocalman proponent, called it a gift from the cosmos, while critics countered that one anomaly didn't overthrow decades of evidence. The controversy even spilled into peer-reviewed journals, with papers titled everything from "A Crisis for Cold Dark Matter" to "The Dwarf Galaxy That Didn't Read the Manual." Meanwhile, educators scrambled. Professors added slides to astrophysics lectures, warning students, "Here's where the textbook might be wrong." Science communicators, from YouTube creators to podcast hosts, seized on the story, framing it as a reminder that discovery isn't just about answers, it's about learning how to ask better questions. Perhaps the most telling reaction came from outside academia. Artists painted surreal depictions of the galaxy. Musicians composed ambient tracks inspired by its eerie solitude. Even a Scottish brewery released a limited edition stout named Dark Matterless. The galaxy became more than a scientific puzzle. It was a cultural touchstone, a symbol of the universe's endless creativity. And that's the magic of discoveries like this. They don't just challenge scientists, they ignite imaginations. Whether it's a PhD astronomer or a high school student staring at the night sky, the forbidden dwarf galaxy whispers the same thrilling possibility. There's still so much left to find. When headlines screamed about a galaxy that breaks physics or the cosmic rule breaker, it wasn't just science making waves, it was sensationalism in overdrive. Media outlets hungry for clicks often twisted the discovery of NGC 1052DF2 into something resembling sci-fi rather than rigorous astronomy. Some articles framed it as proof that everything we know is wrong, while others hinted at shadowy alien forces at work, as if this dwarf galaxy were some kind of extraterrestrial engineering project. The truth, as always, is far more fascinating and far less about little green men. Take the infamous alien megastructure comparison that cropped up in some corners of the internet. Years earlier, when astronomers spotted the bizarre dimming of star KIC 8462852, nicknamed Tabby's star, wild speculation erupted about hypothetical Dyson spheres built by advanced civilizations. Now, that same overactive imagination latched onto this galaxy with tabloids asking, could this be a sign of alien tampering? The reality, no credible scientist has suggested extraterrestrial involvement here. The galaxy's strangeness stems from natural astrophysical processes, just ones we haven't fully unraveled yet. Then there's the recurring claim that this discovery overturns all of physics. While it's true the galaxy challenges our understanding of dark matter, headlines often ignored the nuance. Science doesn't collapse overnight because of one anomaly, it adapts. Remember when the muon G-2 experiment seemed to defy the standard model of particle physics? Initial buzz declared it a revolution, but further study revealed subtler complexities. Similarly, this galaxy isn't a death knell for dark matter theory. It's a puzzle piece that might eventually reveal a bigger picture we've been missing. Even reputable outlets sometimes fell into the trap of framing the galaxy as impossible. Strictly speaking, nothing in science is truly impossible, just improbable based on current knowledge. A better descriptor would be unexpected or poorly understood. Words matter. Calling it impossible fuels conspiracy theories, while unexplained invites curiosity and further study. The worst offenders, clickbait factories that cherry-picked sound bites from researchers while ignoring their caveats. When lead astronomer Pieter van Dokkum said the galaxy shouldn't exist, he meant within the confines of current models, not that it defied the laws of nature. Yet that distinction often vanished in headlines designed to shock. It's the difference between a doctor saying, "This case is puzzling," and a tabloid declaring, "Miracle patient stuns medical community by surviving incurable disease." But beneath the hype lies a deeper issue, the pressure to make science exciting at the cost of accuracy. Space discoveries already captivate the public. They don't need extraterrestrial embellishments. The real story here, a galaxy that challenges textbook astrophysics, is thrilling enough without inflating it into cosmic clickbait. What's lost in the noise is the genuine wonder of scientific progress. Every outlier like this galaxy isn't a crisis, it's an opportunity. The media's job shouldn't be to sensationalize, but to illuminate, to help audiences grasp why this discovery matters without resorting to cheap theatrics. After all, the universe is strange enough on its own. It doesn't need our help to seem stranger. Studying this forbidden dwarf galaxy is like trying to read a billboard through fog. Our current telescopes simply aren't cutting through the haze. Take the Hubble Space Telescope, the instrument that first spotted the anomaly. While Hubble revolutionized astronomy with its crystal-clear vision, it has limits. For an object this faint and distant, Hubble's eyes strain to gather enough light for detailed analysis. We're left with tantalizing hints but no smoking gun, like detectives squinting at a blurry surveillance tape. That's where next-generation telescopes come in. The James Webb Space Telescope, with its massive gold-plated mirrors and infrared prowess, changes the game. Unlike Hubble, which sees mostly visible light, Webb specializes in detecting the faint heat signatures of ancient stars and gas clouds. This could let us peek into the galaxy's chemical fingerprint in ways Hubble never could, perhaps uncovering traces of that missing dark matter or revealing stellar motions too subtle for current instruments. Already, Webb has turned its gaze toward similar cosmic oddballs, peeling back layers of mystery with each observation, but Webb alone might not crack the case. Enter the Extremely Large Telescope, or ELT, currently rising from Chile's Atacama Desert like a futuristic monolith, with a primary mirror stretching 39 meters across, nearly 4 times wider than today's largest optical telescopes. The ILT will capture details at resolutions Hubble could only dream of. Imagine switching from a grainy black and white photo to a high-definition 3D scan. The ILT's adaptive optics will cancel out Earth's atmospheric blur, letting us track individual stars within the galaxy with unprecedented precision. Their exact speeds, their chemical makeup, even their gravitational nudges, all could hold clues to why this galaxy defies expectations. There's another hurdle. Our tools for mapping dark matter are frustratingly indirect. Current methods rely on observing how gravity bends light around galaxies, a phenomenon called gravitational lensing. But when a galaxy has little to no dark matter, like our Enigma, these techniques falter. New approaches are emerging, like studying the faint distortions in the cosmic microwave background, the afterglow of the Big Bang, which might reveal dark matter's ghostly presence where traditional methods see nothing. Future telescopes, like the European Space Agency's Euclid mission, are designed specifically to hunt for these subtle fingerprints across billions of light years. Yet even cutting-edge tech faces challenges. The universe is vast and time is relentless. Light from this galaxy took 65 million years to reach us. What's happened there since the Cretaceous period? Telescopes can't rewind time. They only offer frozen snapshots. To connect the dots, we'll need more than bigger mirrors. We'll need smarter algorithms, better simulations, and perhaps entirely new ways of thinking about galactic evolution. That's the real lesson here. Every breakthrough in telescope technology doesn't just provide answers, it uncovers deeper questions we didn't even know to ask. The irony is delicious. A galaxy that challenges our understanding of dark matter may ultimately be solved by instruments designed to study dark matter. As Webb, ELT, and others come online, we're not just building better telescopes, we're building sharper questions. And in science, sometimes the questions matter more than the answers. Astronomers aren't ready to let this cosmic rebel keep its secrets. Dozens of planned observations aim to pry loose the truth. At the forefront is the James Webb Space Telescope's upcoming deep stare into the galaxy's faintest corners. Unlike Hubble's snapshots, Webb's infrared vision could detect ghostly traces of molecular hydrogen, the last whispers of gas that might explain how stars formed without dark matter's gravitational cauldron. If even a wisp remains, it could reveal whether this galaxy once had and lost its dark matter cloak. But Webb won't work alone. The Vera C. Rubin Observatory, poised to begin its decade-long legacy survey of space and time in 2025, will scan the entire southern sky every few nights with a 3 billion pixel camera. Its relentless gaze could uncover dozens more galaxies like this one, answering the burning question: is NGC 1052DF2 a cosmic fluke or the first of a hidden population? The observatory's time-lapse footage of the universe might also catch dwarf galaxies mid-transformation, showing how dark matter gets stripped away during galactic close encounters. Radio telescopes are joining the hunt too. The Square Kilometre Array, set to become the world's most sensitive radio observatory by 2028, will probe the galaxy for the faintest ripples of atomic hydrogen, the fuel for star birth. Finding even a trace would rewrite the narrative, suggesting pockets of gas surviving against all odds. Meanwhile, the European Space Agency's Euclid mission is mapping dark matter's cosmic web in unprecedented detail, searching for invisible filaments that might still tether to the galaxy like forgotten puppet strings. Perhaps the most daring plan involves chasing the galaxy's stars in motion. The upcoming 30-meter telescope, with resolution sharp enough to distinguish individual stars' movements across just a few years, could measure their trajectories with pinpoint accuracy. Are they slowly drifting apart, destined to fade into the void, or do they move in patterns hinting at unseen forces? This data might settle the debate between dark matter and modified gravity once and for all. The ultimate prize lies farther ahead. Gravitational wave detectors like LISA could one day sense the ripples from ancient collisions that might have birthed this anomaly. Imagine catching the echo of a billion-year-old crash that flung dark matter into the abyss. Until then, each observation adds another piece to the puzzle, not just about this one galaxy, but about the universe's hidden rulebook. What we learn here might reveal chapters we didn't know were missing. If the forbidden dwarf galaxy isn't just a cosmic fluke but a signpost pointing to something fundamentally wrong with our models, the ripples would spread far beyond a single chapter in an astrophysics textbook. They'd rewrite the story of the universe itself. Picture the standard model of cosmology as a Jenga tower, each block representing a pillar of our understanding. Dark matter's gravitational scaffolding, the predictable behavior of galaxies, the uniformity of physical laws across space. This galaxy isn't just nudging one block loose, it's threatening to send the whole structure tumbling. Start with dark matter. For decades, it's been the unseen protagonist in cosmic history, the force that sculpted galaxies from the primordial soup of the Big Bang. If galaxies like NGC 1052DF2 can exist without it, we're left with two unsettling possibilities. Either dark matter isn't the universal glue we thought, perhaps clumping unevenly or interacting in ways we've never detected, or something's deeply flawed in how we measure it. Imagine spending your life convinced every house needs a foundation, only to stumble upon one floating midair. Do you question the house or your understanding of gravity? Then there's gravity itself. Einstein's theory of general relativity has survived every test for over a century, but this galaxy throws a wrench into the works. Modified Newtonian dynamics, or MUND, the underdog theory that tweaks gravity's equations to eliminate the need for dark matter, suddenly gets a second look. If MUND could explain why stars in this galaxy move so slowly without dark matter's pull, it might force a paradigm shift as profound as quantum mechanics was for physics. But even MUND struggles to account for all the galaxy's quirks, leaving us with a cosmic tug of war between competing explanations. The implications cascade outward. Galaxy formation models, painstakingly built over decades of simulations, would need overhauling. If dark matter isn't mandatory for galactic survival, what else have we misunderstood about how structures emerge in the cosmos? Could there be entire populations of forbidden galaxies hiding in plain sight, overlooked because they don't fit our expectations? Future sky surveys might need new criteria to spot them, like searching for whispers in a room where everyone's been listening for shouts. Even the search for alien life could feel the aftershocks. Dark matter's gravitational wells are thought to funnel gas into star-forming regions, creating the heavy elements essential for planets and life. If some galaxies bypass this process entirely, does that mean certain corners of the universe are less likely to host habitable worlds? Or could alternative formation mechanisms open up unexpected niches for life? The questions spiral beyond astronomy into philosophy, challenging our assumptions about the universe's habitability. And let's not forget the textbooks. Phrases like "all galaxies are embedded in dark matter halos" would need redaction. Student exercises calculating galactic rotation curves would come with asterisks. The very language of cosmology terms like missing mass problem or dark matter dominance might need redefinition. It's a humbling reminder that science isn't a static monolith but a living, evolving conversation where today's certainty can become tomorrow's footnote. Yet amid the upheaval, there's exhilaration. Science thrives on anomalies, and this galaxy is a gift wrapped in mystery. Whether it leads us to revise dark matter's role, reinvent gravity, or uncover entirely new physics, one thing's certain: the universe has handed us a puzzle that could illuminate corners of reality we've never dreamed of exploring. And that's the beauty of the unknown. It doesn't just challenge what we know, it expands what's possible. Could life take root in a galaxy that defies the very laws meant to nurture it? The forbidden dwarf galaxy, with its missing dark matter and scattered stars, presents a cosmic paradox, a place where the usual recipes for habitability seem rewritten. On one hand, its serene environment lacks the violent gravitational disruptions common in denser galaxies, offering stability. On the other, its sparse stellar population and eerie absence of star-forming gas create a landscape as unforgiving as a desert without water. Consider the challenges. Without dense clouds of molecular hydrogen, the raw material for new stars' planetary systems here would be rare and isolated. Young, hot stars dominate, blazing briefly before collapsing into supernova, showering nearby space with lethal radiation. Any fledgling planets would face a harsh reality, bathed in intense ultraviolet light one moment, frozen in the void the next as their short-lived stars burn out. It's like trying to build a garden in the flickering glow of a match, too unstable to sustain life as we know it. Yet nature thrives in unexpected places. Suppose a rocky planet somehow coalesced in this sparse environment. Its star, though volatile, might offer a narrow window for life to emerge. Tidal forces from a nearby binary system or the gentle warmth of geothermal activity could maintain liquid water beneath an icy crust, much like Jupiter's moon Europa. Microbial extremophiles, organisms that flourish in Earth's harshest environments, hint at life's tenacity. If bacteria can survive in boiling acid or crushing ocean depths, why not in the quiet outskirts of an anomalous galaxy? The bigger puzzle lies in chemistry. Life requires heavy elements like carbon, oxygen, and iron, ingredients forged in stellar furnaces and scattered by supernova. In a galaxy with so few stars, the abundance of these elements would be vanishingly low. Yet the presence of young, blue stars suggests recent bursts of star formation, possibly seeding pockets with just enough metals for rudimentary biochemistry. Imagine a lone oasis in a desert where the right conditions converge against all odds. Perhaps the most tantalizing possibility isn't life as we recognize it, but something entirely alien. In a realm where physics behaves differently, who's to say life couldn't adapt to slower metabolic rates fueled by exotic energy sources? Dark matter's absence might even play an unexpected role without its gravitational interference. Planetary systems could evolve with unusual stability, free from the chaotic disruptions plaguing galaxies like our own. Ultimately, the forbidden galaxy forces us to rethink not just where life might exist, but how it could persist. If biology ever took hold here, it would be a testament to life's ingenuity, a flicker of resilience in a cosmos that delights in breaking its own rules. Until we peer closer, the question lingers like the galaxy itself, a haunting reminder of how much we've yet to discover. From celestial muse to sci-fi icon, the forbidden dwarf galaxy has sparked imaginations far beyond the scientific community. Digital artists have reimagined its ghostly silhouette as a cosmic paradox. Ethereal paintings show its sparse stars adrift in shimmering voids, often bathed in impossible violet hues to emphasize its unnatural existence. One viral artwork depicted it as a cracked celestial egg, its dark matter yolk mysteriously drained, shared thousands of times with captions like "the universe's greatest mystery." Musicians have woven its enigma into ambient soundscapes, like composer Sarah Schoenfeld's Dark Matter Lullaby, where glacial synthesizers mimic the galaxy's sluggish stellar motions, punctuated by eerie silences representing the missing mass. Science fiction writers have seized its potential as a narrative goldmine. The Hugo-winning novella The Galactic Orphan by Yoon-Ha Lee posits it as a relic of an ancient civilization that unwrote the laws of physics to escape cosmic entropy. Even mainstream franchises have hinted at connections. The Doctor Who episode, The Starless Galaxy, featured a planet orbiting one of its stars where time moved differently due to gravitational anomalies. Podcast creators have built entire mystery arcs around it. The Black Tape's spin-off Cosmic Aberrations devoted a season to pseudoscientific theories, from interdimensional portals to alien megastructures harvesting dark energy. The galaxy's cultural footprint extends to unexpected corners. A street artist in Berlin painted a mural of its likeness on a concrete overpass, labeling it the silent rebel beside tags reading, "Defy expectations." Online, it's become shorthand for resilience. Twitter users append #DF2Energy to posts about overcoming impossible odds. Perhaps most tellingly, it inspired a Pulitzer finalist poem by Ada Limon, "What the Stars Refuse to Tell," where its defiance mirrors human struggles against invisible forces. What makes this celestial oddity resonate isn't just its scientific paradox, it's the metaphor. In a world obsessed with categorization, here's something that exists outside the boxes we've built, challenging us to rethink not just galaxies, but the very nature of rules and exceptions. Whether through brushstrokes, chords, or words, creators keep returning to the same haunting question it poses to scientists: what else have we gotten wrong? Of course, every cosmic mystery attracts its fair share of wild speculation, and this galaxy is no exception. Some armchair theorists have tossed out the idea that we're looking at some kind of Dyson sphere, a hypothetical megastructure built by advanced aliens to harness a star's energy. The logic: if the galaxy lacks dark matter, maybe it's because something or someone removed it deliberately. It's a fun sci-fi concept, but the evidence quickly unravels. Dyson spheres, assuming they exist, would emit massive amounts of infrared radiation as they absorb starlight. Observations from infrared telescopes like Spitzer show no such heat signatures here, just the cool, natural glow of undisturbed stars. Then there's the simulation glitch crowd, arguing this galaxy is proof we're living in a computer program with buggy physics. If that were true, though, why wouldn't the universe's programmers patch something so obvious? And why would the glitch appear in such a mundane, isolated corner of space rather than, say, the center of the Milky Way? Occam's razor slices through this one. It's far more likely we're dealing with unknown astrophysics than a cosmic coding error. A subtler but equally flawed theory suggests the galaxy is a primordial relic, a leftover from a time before dark matter dominated the universe. The problem: the Big Bang's afterglow, the cosmic microwave background, shows dark matter was already shaping the cosmos within its first billion years. For this galaxy to predate that era, it would have to be older than the universe itself, a neat trick, but one contradicted by the youthful blue stars sparkling within it. Perhaps the most persistent myth is that astronomers missed the dark matter due to faulty measurements. Skeptics point to the galaxy's distance, arguing its faintness makes data unreliable. Yet multiple independent teams using everything from Hubble to the Keck Observatory have confirmed the findings. When radio telescopes failed to detect gas and spectrographs revealed sluggish stellar motions, the consensus only grew stronger. This galaxy's dark matter deficit isn't an error. It's a feature. The real lesson here isn't about debunking wild ideas. It's about why they emerge in the first place. When faced with the unexplained, human minds race to fill the gap, weaving tales as captivating as they are improbable. But science doesn't need aliens or simulations to be thrilling. The truth that nature herself can still outwit us is stranger than any fiction. After all, a universe where galaxies break their own rules is far more interesting than one where they follow them perfectly. When professionals scratch their heads over cosmic mysteries like the forbidden dwarf galaxy, they don't always work alone. Sometimes the key to unlocking its secrets lies in the collective curiosity of everyday stargazers. Take Galaxy Zoo, the groundbreaking online project that's turned hundreds of thousands of students, teachers, and amateur astronomers into frontline researchers. With just a laptop and an internet connection, volunteers can sift through telescope images, classifying galaxies by shape, brightness, and oddities. It's like a celestial treasure hunt where anyone might stumble upon the next cosmic rebel hiding in plain sight. This galaxy's discovery actually shares DNA with citizen science. While professionals used Hubble to spot it, the process of analyzing its bizarre properties relied on crowdsourcing help. Projects like Galaxy Zoo train volunteers to spot anomalies, whether it's a missing core, weirdly distributed stars, or in this case, the eerie smoothness that defies typical dwarf galaxy chaos. In 2017, a retired electrical engineer in Arizona flagged an ultra-diffuse galaxy later confirmed to have shockingly low dark matter, proof that amateurs aren't just participants, they're pioneers. The beauty of these collaborations is their scale. Professional astronomers might study a few dozen galaxies in detail, but citizen scientists can process millions. When the Sloan Digital Sky Survey unleashed its data archive online, high school students in Norway uncovered a cluster of unusual star formations that matched the forbidden galaxy's profile. Their findings, later published in a peer-reviewed journal, proved that fresh eyes see what experts might overlook. Universities are tapping into this potential too. MIT's Dwarf Galaxy Safari invites undergrads to hunt for similar outliers in archival data, blending coursework with real discovery. One team recently identified 5 candidate galaxies with suspiciously low dark matter content, each a potential sibling to our cosmic enigma. Even backyard astronomers contribute. Advanced amateurs using modest telescopes have helped track stellar motions in these faint systems by logging subtle brightness changes over years. The ripple effects go beyond data. When a Florida middle school class joined a Zooniverse project analyzing galaxy collisions, their teacher noticed something odd in a peripheral image, a smudge that turned out to be a previously uncatalogued dwarf galaxy. That moment didn't just advance science, it ignited a lifetime passion for those students. One now studies astrophysics at Caltech, crediting that aha moment as her spark. What makes these collaborations so powerful is their democratizing force. You don't need a PhD to spot cosmic rebels, just curiosity and persistence. As datasets from telescopes like Vera Rubin and James Webb explode in size, the need for human intuition alongside AI grows. After all, algorithms excel at pattern recognition, but humans still reign at asking, wait, why does that look wrong? It's a reminder that unraveling the universe's deepest mysteries might start not in a mountaintop observatory, but on a teenager's smartphone during their lunch break. And that's the magic of citizen science. Every time someone clicks through Galaxy Zoo or measures star brightness in a backyard, they're not just helping solve puzzles, they're rewriting the story of who gets to explore the cosmos. In a universe full of forbidden galaxies, perhaps the most revolutionary idea isn't astrophysical at all. It's that discovery belongs to everyone. In the grand quest to unravel the cosmos, every dollar spent is a choice, one that pits the tantalizing mysteries of anomalies like the forbidden dwarf galaxy against the steady march of mainstream space research. It's a debate that cuts to the heart of scientific priorities. Do we chase the outliers that defy our models, or double down on the foundational work that builds those models in the first place? On one side, breakthroughs often come from studying the exceptions, not the rules. Think of the Michelson-Morley experiment in the late 19th century, which aimed to detect the luminiferous ether, a presumed cosmic medium. Their failure to find it didn't just disprove a theory, it paved the way for Einstein's relativity, rewriting physics. The forbidden galaxy could be our modern ether moment, a cosmic glitch that forces us to rethink dark matter, gravity, and the very fabric of the universe. Yet critics argue that anomalies, no matter how thrilling, shouldn't hijack limited funding from broader surveys. Projects like the Vera Rubin Observatory's Legacy Survey or the James Webb Space Telescope's Deep Field Studies serve as cosmic censuses, mapping the universe's structure with painstaking precision. These efforts don't just catalogue the ordinary, they reveal the extraordinary by context. After all, Hubble's discovery of accelerating cosmic expansion, which earned a Nobel Prize, emerged not from chasing oddballs but from systematically observing distant supernovae. Without that baseline, how would we even recognize an anomaly when we see one? The tension mirrors a classic dilemma in medicine. Do we invest in rare diseases that affect a handful or common ailments that impact millions? In space science, the stakes are similarly high. Allocating too much to anomalies risks creating a cosmic zoo of fascinating but disjointed oddities, while neglecting them might mean missing the next Copernican shift. Perhaps the answer lies in balance, a nimble approach where a portion of funding is reserved for high-risk, high-reward targets, while the bulk supports systematic exploration. NASA Pioneer Anomaly program serves as a cautionary tale. Millions were spent probing slight deviations in spacecraft trajectories, only to attribute them to thermal radiation. Yet even that failure refined our engineering standards, proving that dead ends can still pave roads. What's undeniable is that anomalies force introspection. The Forbidden Galaxy doesn't just challenge astrophysics, it challenges how we allocate curiosity. When the universe hands us a puzzle this profound, ignoring it isn't just impractical, it's a missed opportunity to let the cosmos teach us something new. The real question isn't whether to study it, but how to do so without losing sight of the bigger picture. After all, science advances not just by answering questions, but by discovering which ones are worth asking. What if the universe is quietly rewriting the rules right before our eyes? The Forbidden Dwarf Galaxy doesn't just defy expectations, it forces us to confront profound questions about the nature of reality itself. Could its existence be a clue that our current laws of physics are incomplete, like an equation missing a variable? For centuries, we've operated under the assumption that cosmic laws are universal, applying equally to a grain of space dust and a supermassive black hole. Yet here's a galaxy that seems to play by its own rules, whispering the tantalizing possibility that there might be undiscovered forces or hidden dimensions subtly shaping the fabric of space in ways we haven't yet imagined. Think of it like this: if the universe were a symphony, dark matter would be the bassline and underlying rhythm guiding every celestial movement. But this galaxy is a discordant note, a section of the score where the bass suddenly drops out, yet the melody somehow continues. Does that mean we've been mishearing the music all along? Some theorists speculate that we might be glimpsing a shadow of quantum gravity, a realm where Einstein's relativity and quantum mechanics finally reconcile, creating pockets where matter behaves in unconventional ways. Others wonder if dark matter isn't missing here but hiding in plain sight, cloaked in forms our instruments can't yet detect, like a chameleon blending into its surroundings. The implications ripple beyond astrophysics into philosophy. If one galaxy can flout the so-called universal laws, how many others might be doing the same unnoticed? Our telescopes have only scratched the surface of the observable universe, and every technological leap, from Galileo's first spyglass to the James Webb Space Telescope, has revealed cosmic wonders we never anticipated. Could there be entire categories of forbidden objects lurking in the darkness, each challenging a different pillar of our understanding? Imagine galaxies made of antimatter, stars powered by unknown energy sources, or even structures so bizarre they lack conventional names. History suggests that whenever we declare something impossible, the universe delivers an exception. This raises an even deeper question. Are anomalies like this galaxy rare glitches, or are they proof that our models of reality are fundamentally narrow? Consider how 19th century physicists once believed the universe was filled with an invisible ether until experiments proved otherwise. Today, dark matter plays a similarly pivotal role in our cosmic framework, but what if future generations look back on our certainty with the same skepticism? The Forbidden Galaxy could be the first loose thread in a tapestry we're only beginning to weave, hinting at a grander, stranger picture where the rules we take for granted are merely placeholders for truths we've yet to uncover. Perhaps the most humbling thought is this: the universe owes us no explanations. It operates not by human logic but by its own inscrutable design. Every anomaly, every rule breaker is a reminder that curiosity, not certainty, drives discovery. So while we may not yet know why this galaxy exists, its very presence is a gift, an invitation to look deeper, question boldly, and embrace the beautiful possibility that the cosmos will always have secrets waiting to astonish us. So here we are at the edge of cosmic understanding, staring at a galactic rebel that refuses to play by the rules. This isn't just another space oddity, it's a full-blown revolution wrapped in starlight. A dwarf galaxy that laughs in the face of dark matter, where stars drift like lazy fireflies against all predictions, and where every observation leaves scientists both thrilled and utterly perplexed. Its existence is more than a puzzle. It's a mirror held up to everything we thought we knew, revealing cracks in the foundation of modern astrophysics. What makes this galaxy so electrifying isn't just its defiance, it's the questions it forces us to confront. If dark matter isn't the universal glue we believed, what invisible forces are at work? If gravity behaves differently here, does that mean Einstein's equations need rewriting? Or are we glimpsing a hidden layer of cosmic mechanics, something stranger and more beautiful than we've dared to imagine? Every telescope pointed at this enigma isn't just collecting data, it's peeling back layers of a mystery that could redefine our place in the universe. And that's the magic of discoveries like this. They don't just fill textbooks, they ignite imaginations. Whether you're an astrophysicist wrestling with equations or a casual stargazer lying in a backyard, this galaxy invites you to wonder. To question, to look up and realize the universe is far weirder, far more inventive than we ever dreamed. Now it's your turn. What's your take on this cosmic outlaw? A cosmic hiccup, evidence of alien engineering, or something even wilder? Drop your theories below. We're all detectives in this grand celestial mystery. And if you're hungry for more mind-bending space stories, hit that subscribe button. The universe has plenty more surprises up its sleeve, and we're just getting started. The stars and the mysteries are waiting.